Hello and welcome back to Credit 4 of Algebra 1A with Lesson 9.4, Normal Distributions. We're going to start on page 23. Why is normal distribution important? So, it's important because it fits many things that we see in the real world. For example, the height of a person versus the weight of a person, or blood pressure, kind of follows a normal distribution pattern. So most people kind of fall within this normal curve when it comes to height and weight. This is one of the ways we kind of use this. Also for test scores or error rates or blood pressure, just to see if things are in the normal range. Okay, hence the word normal. So as you can see here, we have the scores of all sixth graders of a school for a statewide test that is normally distributed. So it says the mean is 76 and the standard deviation is 10. So the mean, we're going to highlight some stuff. So if you don't have a highlighter, go ahead and underline. That's fine. So the mean is 76 and the standard deviation is 10. So they give us this shape, and notice, yes, I am skipping a few steps on the packet, going straight to drawing and shading the normal curve. So here for the normal mean, which is right here in the middle, we're going to put 76. Now to fill in the rest of these spaces here, I'm going to write those in. We're going to continually add by the standard deviation. In this case, the standard deviation is 10. So we're going to go ahead and take a moment right now and continually add 10 to fill in these spaces. And unpause, that would be 86, 96, and 106. If I wanted to go backwards in the opposite direction, notice how it's a negative. So I'm going to go ahead and subtract 10 instead. So go ahead and take a moment right now and subtract 10 from 76 and continue to do so to fill out the rest. And unpause, that would be about 66, 56, and 46. So the question's asking, what is a percent that of the scores are below 56? So looking at the numbers here, go ahead and find 56 and draw a circle on it. You'll notice 56 is right here. What are some scores that are below 56? Would that be scores on the left or scores on the right? That would be scores on the left. So we're going to add up these percentages. Go ahead and take a moment and do that now. And that would be about 2.5% of the scores for all sixth graders in Robert's school are below 56. Okay, that's pretty good. Yeah. So only a few who are below that average or mean. The majority are doing pretty well, which is good. All right. On this next problem, again, it's the same school with the same mean and standard deviation. So this is what percent of scores were above 66. So you can kind of recalculate all these numbers out, or we can just recopy all the numbers we just did, where we continually add by 10 and subtract by 10. And you're like, why are they making us fill out a whole new thing for the same problem? Because we're asking for what of the scores are above 66. So go ahead right now and circle, where is 66? All right. So scores that are above, would that be this side or this side? Which side are above 66? That would be that side. So we're going to add up all those numbers up. Go ahead and take a moment to do that. And unpause, that would be 84. 84% of the scores of all sixth graders at Roberts School were above 66. All right, moving on. If at any point I'm going too fast, please pause. For here, we're talking about pennies that are minted in the United States after 1982 as normally distributed, with a mean of 2.5 grams and a standard deviation of 0.02 grams. So I'm going to write that in. And we're going to fill in our standard deviation and our mean. So that would be about 2.5. And we're going to continually add by our standard deviation, which is 0.02. So go ahead and take a moment and go ahead and continually add 0.02 to this to fill in these spaces. That would be 2.52, 2.54, and 2.56. Going the opposite direction, let's go ahead and subtract. Take a moment to fill in these spaces by subtracting by 0.02. And that would be 2.48, 2.46, and 2.44. So here are the numbers for 2.44. Go ahead and circle 2.44 and 2.56. And that would be here and here. What are the masses in between? Well, it'd be all of these, right? So we're going to go ahead and take a moment and add all these percents up. And hopefully you paused and did that. That would be about 99.7% that are minted between the masses of 2.44 and 2.56. All right, so the standard deviation is asking us to do kind of the same thing. We're going to be given a mean, standard deviation. We're going to be asked to find a couple of questions. So go ahead and do that. For the homework, which is from the textbook, it might be helpful to, again, use a standard deviation picture, which is why I use that there. A couple of words that might be new from the lesson is the words no more than and at least. So the word no more than means it could be less than that particular number, but it can't be any more than that. At least means that it could be more than that number, but not any less. All right, so kind of follow the same patterns. Find your mean, use your standard deviation to kind of fill in these spaces here, and then use this normal distribution to answer numbers 1, 2, and 3, and 4 as well. All right, and then for 11, 12, 13, and 14, again, you're going to kind of fill in your normal distribution using the numbers that they give you for your mean and for your standard deviation. And you're also just finding, again, the word no more than means it could be less, but no more than 68. And for 13 and 14, at least means it can be more, but it can't be less than 76. If you have any questions on any of the homework, please come into the center. We're more than happy to help you with any of the questions you might have. See you on the next video.